Write the quadratic equations whose solutions are give in standard form with integer coefficients. So we can have fractional coefficients. This is kind of working backwards. Recall, if I have something like, let's say, x squared minus 3x minus 4 equals 0, this would be a quadratic equation. It's already set to 0. I would factor that and I would have something like x minus 4, x plus 1 equals 0, and that would pop out two solutions, 4 and -1. So now I'm going to retrace my steps sort of backwards, and I really have these two solutions. I'm going to go there, and then from here I'm going to go up again. So the two solutions that are given to me are basically x equals -2 and x equals 1. Remember, it said quadratic equations whose solutions are given. So these are my two solutions for the quadratic equation. I'm going to go backwards here. I'm going to say that must have come from two binomials, x minus the first one and x minus the second one. Because notice, if this is a 4, that's x minus 4. If this is a -1, that's actually x plus a 1. It's the opposite of what got popped out. So this is actually an x plus 2. So I have x plus 2, x minus 1 equals 0. That's really my quadratic equation, but it said give it in standard form, so I gotta multiply this out. That's going to be x squared minus x plus 2x minus 2 equals 0. X squared plus 1x minus 2 equals 0, and that must have been the quadratic equation that led me to come up with these two answers, -1 and, or -2 and 1. So all we did was retrace our steps backwards. The two solutions were popped, we put them back into the binomials, we multiply everything out, and we get the equation we must have started with. Let's do the same thing for part B. So I'm going to go backwards. They must have come from two binomials, x minus a minus 3, so x plus 3, and then x minus 1/2. So these are my two binomials. I'm going to multiply them out. That's going to be x squared minus 1/2 x plus 3x minus 3/2 equals 0. I don't like those fractions. I'm not going to mess with them because it's an equation. I'm going to go multiply all the chunks by the 2 to cancel things out. Remember, every single chunk must get multiplied by 2. So that's going to give me 2x squared minus a 1x plus 6x minus just a 3, and 2 times 0 is 0. So that's going to give me 2x squared plus 5x minus 3 equals 0. In other words, these two solutions must have popped out of this original quadratic equation. So all we did again was retrace our steps backwards. Okay, an object is thrown into the air from a height of s0, is how it's pronounced, above the ground with an initial velocity of v0, that's how you pronounce that. Then its height t seconds later is given by this formula. So they gave us a formula, but they don't tell us exactly what these things are yet. It says where g is the constant that measures the force of gravity, use this formula to answer problem 16. Alright, so a tennis ball gets thrown into the air with an initial velocity of 16 feet per second. That's the initial velocity, which in our case is v0. So I have to plug that in here. That's going to be my 16. From a height of 8 feet. So the height originally was 8 feet, and they told us the original height above the ground is s0. So 8 feet is the s0. I put that there. And also the value of g in this problem is 32. So we know 32 goes right there. That's going to give me the equation that gives the height of the tennis ball at time t. So h equals -1/2. Let's plug in the 32 for the g value. That's going to be t squared plus v0 is going to be the 16 feet per second t plus s0 is going to be 8 feet. And once I simplify that, I get -16 t squared plus 16t plus h, or plus 8, I'm sorry. So basically they had to give me the value of g, v naught, and s naught for me to be able to give the final equation for the height of this tennis ball. So if I'm thinking of this tennis ball, it's starting 8 feet above the ground, and then somebody throws it up, it goes up, and of course eventually comes down. That's basically what's going on. Part B says find height of the tennis ball at half a second and at 1 second. Well, I plug in half a second for my time, and I get h equals 8 feet, or no, actually 8 would be initially when t is 0. Punch that in on my calculator and I'm getting 12 feet at t equals 1/2. And then it also says do it for 1 second later, so I'm going to go ahead and plug in 1, and that gives me 8 feet at 1 second later, which means 1 second later it was already on its way down, because initially, remember, at t equals 0 it was at 8 feet up off the ground. It must have gone up and then come down again. On its way down, it looks like 1 second later was already back at the 8 feet. So halfway in between is half a second. I'm already thinking this 12 feet might be the maximum height of this tennis ball. But let's keep reading. Write and solve part C an equation to answer the question, at what time is the tennis ball 11 feet high? Well, here's my equation right here. 11 feet high is what the h needs to be. So I gotta plug that in and then solve that quadratic equation by setting it equal to 0 to see what'll happen. That'll be 16t squared plus 16t minus 3. And did it say to solve it? It didn't really say to solve it just yet. It just said write and, oh no, it did say solve it. So we gotta keep solving this, keep going. So now I'm gonna move the negative 16 up and multiply it by the 3. Whatever method you use to factor, it's up to you. That's going to give me a positive t squared plus a 16t, negative 16, and negative 3 is a positive 48. That'll help me solve, or factor, I'm sorry, t plus plus. Two numbers, I guess 4 and 12 would work. That would give me a sum of 16. But since I multiplied by negative 16, I gotta divide these guys by negative 16. And then reduce and see what happens. So now I got 0 equals t minus a fourth, it looks like, and t minus, they're both divisible by 4, 3/4. Now I'm going to move, it's completely simplified, I'm going to move these guys up, and we have 0 equals 4t minus 1 and 4t minus 3. And we're going to set each one equal to 0. I get t equals 1/4 when I move the 1 over and divide by 4. And I get t equals 3/4 when I move the 3 over and divide by 4. So at 1/4 of a second later and 3/4 of a second later, we got the ball 11 feet high. So if I go back to my visual here, 11 feet high happens like maybe somewhere here and here, and that's 1/4 of a second later and 3/4 of a second later. And right in the middle there's a high point, my vertex, which again I'm guessing to be 12 feet high because it's right smack in between these guys and it appears to be the highest point. Okay, part D I won't do since not all of you have the TI. Part E, graph your equation of the tennis ball's height on your calculator. I'm just going to go ahead and do it by hand here because we have enough information. We know that it started at 8 feet above the ground. Again, I'm doing a rough sketch. We know that it went up as high as 12 feet. And we had 1 second, let's say. So I'm just doing a rough sketch. Let me do the label. Okay, so it started 8 feet above the ground, and then we also know from part B that at half a second it was at 12 feet. and at 1 second it was already back down to 8 feet, so it was already on its way down. Make that a little bit more accurate right there. And we know from this part that it was at 11 feet, somewhere here maybe, at the 1/4 second mark and 3/4 second mark. So it was somewhere at 11 feet here, and this guy should be 3/4. And at 11 feet on its way down. So right smack in the middle is going to be, in between these guys is always going to be the vertex. So we know, rough sketch, the parabola looks like that on its way down. So that's part E, just doing the graphing by hand. And we could even find that vertex. We could find the maximum point if we wanted to by looking at t is equal to negative b over 2a. And let's do that quickly. B in my problem is 16, so negative 16. And 2a, a is negative 16, 2 times negative 16, sure enough, is going to be a positive 1/2. Now I know for sure that's my maximum, that's my vertex, 1/2, comma, 12. 12 feet is the highest the tennis ball goes. Now part F, it says, if nobody hits the tennis ball, approximately how long will it be in the air? So here's what happened with my tennis ball, you guys. It's right here, it gets hit. It goes up and up and up and up, and then it comes down. So when it comes down and hits the ground, that's going to give me the time interval of how long the tennis ball was up in the air. So this right here, this tells me this x-intercept, or t-intercept in this case, gives me the answer to part F. It tells me how long the tennis ball was in the air. So like this, gets going, some seconds go by, half a second, 3/4 of a second, 1 second is already back down to 8 feet, and at the second it's hit the ground, and we need to find the x-intercept to be able to find what F is. So to find the t-intercept, we must make the h 0. So I'm going to let h be 0. That's when it's going to come and hit the ground, basically. This is what I'm trying to find right here. That's going to help me solve the quadratic equation. Let's try factoring a negative 8 out. That's going to give me a positive 2t squared, a negative 2, and a 2t, and a negative 1. So I pulled out, I like pulling out the negative, and that'll switch all the signs in the middle. I'm going to go ahead and divide by negative 8 just because I kind of want to get it out of the way, and it's an equation and I can do that. Now solving this by factoring won't work, so I'm going to use section 6.3, completing the square. Again, you can use it by looking at your graphing calculator, but here, since not all of you have it, I'm going to do it by completing the square. So I put it in standard form, I moved the 1 over, then I wanted to make sure the leading coefficient is a 1, so I divided everybody by 2, and now I can do the half business. Remember, coefficient here is 1, so half of 1 is 1. We're going to save this, or I'm sorry, that's a half. And then a half squared is a fourth. We're going to use this and add a fourth to both sides. Next, I'm going to factor the left side, which we know will factor into t minus minus, because the middle sign is minus. And it was the guy I saved that always goes in the second spot. Equals, get a common denominator here, that's 2/4 plus 1/4, which is 3/4. Now it looks ready to go. I can square root both sides and get x minus a half equals square root of 3 plus minus over 2, because we know this pops out at 2. So x is equal to add a half to both sides. This nasty thing, however, I have to approximate and see what that answer is to get how long the ball was up in the air. So I have to go use my calculator. And when I do that, for the second one I get a negative number, so I can't have negative time values the way I have my problem set up here. Remember, it starts up here at 8 feet and then it hits the ground at this time, and it looks like that time is going to be at 1.37 seconds later. So at 1.37 seconds is how long the tennis ball was up in the air flying.